Once again I welcome you all to the e-lecture. In the last class we have seen determinants. In determinants, by the method of Cramer's rule, we have to solve the simultaneous equations. Today we are going to see matrices. We have some idea about matrix. So first one, matrix. What is a matrix? A matrix is nothing but a rectangular array of numbers arranged in rows and columns enclosed within parenthesis bracket or square bracket. Right. The horizontal entries are called rows. The vertical entries are called columns. It is denoted by the symbol row R. The column is denoted by the symbol column C. Right. A matrix has, suppose m rows, so R1, R2 and so on, m rows, and a matrix has n columns, then it is said to be a matrix of order m cross n. The first number denotes number of rows, and the second number n denote the number of columns. Right. A row matrix is nothing but if a matrix has a single row but any number of columns. The order is 1 cross n. The order is 1 cross n. N may be any number. Right. Next, column matrix. Suppose a matrix has only one column and any number of rows. Then it is said to be a column matrix. The order is m cross 1. And also we know that square matrix. Suppose the number of rows m is equal to the number of columns n, m equal to n, then it is said to be a square matrix. Here the example is 3 cross 3 matrix or 2 cross 2 matrix. Right. Next, the very important one is transpose of a matrix. Transpose matrix. Let A be any matrix. The transpose of A is denoted by the symbol A transpose, A power T. The transpose of A is denoted by the symbol A transpose, and it is obtained by the rows are interchanged into columns of the original matrix. The first row is written as here. The second row R2 is denoted as, this is column 1, this is column 2, this is column 3. The rows are interchanged into columns or the columns are interchanged into rows. The original matrix உள்ள ரோவெல்லாம் காலமாக மாற்றினாலோ அல்லது காலத்தெல்லாம் ரோவாக மாற்றினாலோ கிடைக்கக்கூடிய மேட்ரிக்ஸுக்கு பேர் வந்து A transpose. Singular matrix. A matrix is capital A is said to be singular if determinant A equal to 0. Determinant value வந்து 0 ஆக இருந்தால் A is said to be singular. Otherwise it is non-singular. For example, A is equal to 1, 6, 2, 12. So determinant A is equal to determinant 1, 6, 2, 12. This is equal to 12 minus 12. This is equal to 0. Therefore the given matrix A is singular. Right. Example number 2. A is equal to 1 minus 6 2 12. So determinant A is equal to determinant 1 minus 6 2 12. This is equal to 12 minus 2 into minus 6 minus 12, so plus 12. This is equal to 24. So determinant A is equal to 24. So A is non-singular. So unit matrix. Any square matrix of order n, that is n cross n, is said to be a unit matrix if all the diagonal entries are 1 and all other entries are zeros. This is a unit matrix of order 3 cross 3. So the unit matrix of order 2 is 1 0 0 1. Unit matrix means the diagonal elements all are 1 and all other entries are 0. Let A be any square matrix. Let A be any square matrix of order n. Suppose A has inverse, then A is non-singular. That is modulus of A not equal to 0. Determinant வந்து not equal to 0 இருந்தால் மட்டும்தான் ஏக்கு இன்வர்ஸ் கண்டுபிடிக்க முடியும். அதர்வைஸ் இன்வர்ஸ் கிடையாது. இன்வர்ஸ் does not exist. So A has inverse. Suppose A has inverse, then A is non-singular. That is modulus of A அல்லது determinant A வந்து not equal to 0. Suppose determinant A equal to 0, then A inverse does not exist. So next, the inverse matrix. Let A be any matrix, any square matrix. Let A be any square matrix of order n. The inverse of A is denoted by the symbol A inverse. It is read as A inverse, such that A into A inverse equal to A inverse A equal to I, where I is the unit matrix. Now we are going to find the inverse of 2 cross 2 matrix and the inverse of 3 cross 3 matrix. So inverse of 2 cross 2 matrix. So let A is equal to A, B, C, D, be any matrix. The inverse of A equal to A inverse. This is equal to 1 by determinant A into adjoint of A. Where the adjoint of A is interchange the elements of A and D. Change the elements B and C. So interchange A and D, change the sign of B and C. So A inverse kuria formula வந்து A inverse equal to 1 by determinant A into adjoint of A. So determinant A நமக்கு ஏற்கனவே கண்டுபிடிக்க தெரியும். ஸோ டிட்டர்மினன்ட் A is equal to ஃபஸ்ட்டில் diagonal elements அப்போ இருக்கும் A into D minus B into C. The adjoint of A எப்படி ஈஸியாக கண்டுபிடிப்போம்னா interchange the diagonal elements A and D ரெண்டையும் இடத்த மாற்றிடணும். ஸோ A and D are replaced, interchanged. Then ஆஃப் diagonal elements அதை தவிர மற்ற ரெண்டு எலிமெண்ட்ஸ் B and C வந்து அந்த எலிமெண்ட்ஸ் அங்கே தான் இருக்கணும், பட் அடையாளம் மட்டும் மாறணும். ஸோ சேஞ்ச் த சைன் ஆஃப் B and C. Therefore A inverse equal to 1 by determinant A, that is AD minus BC into D minus B minus C A. So example is, let A is equal to 1, 2, 3, 4. So we are going to find the inverse of A. So first A inverse equal to 1 by determinant A into adjoint of A. முதல்ல ஃபார்முலா எழுதிக்கணும். Right. So first determinant A கழிக்கணும். So determinant A is equal to determinant 1, 2, 3, 4. This is equal to 1 into 4, 4. Put a sign minus. 2 into 3, 6. 4 minus 6 equal to minus 2. So modulus of A is minus 2. Then adjoint of A. So adjoint of A is equal to interchange A and D, that is diagonal elements வந்து இடம் மாத்துறோம். So ஃபோர் இங்கே வந்துடுது, ஒன்று இங்கே வந்துடுது. சேஞ்ச் த சைன் ஆஃப் B and C. நம்பர்ஸ் அங்கே தான் இருக்கணும். ஸோ 2 வந்து -2 ஆயிடுது, 3 வந்து -3 ஆயிடுது. Therefore A inverse equal to 1 by determinant A. ஆன்சர் என்ன? -2. adjoint of A என்ன? 4 -2 -3 1. Right. Example number 2. Let A is equal to -1, 2, 3, -3, 4. So A inverse equal to 1 by determinant A into adjoint of A. So what is determinant A? So determinant A is equal to determinant -1, 2, -3, 4. This is equal to -1 into 4, -4. Put a sign minus. 2 into -3, -6. அப்போ மைனஸ் என்ன ஆயிரும்? ப்ளஸ் ஆயிரும். ஸோ -4 + 6 equal to 2. So adjoint of A is equal to interchange A and D. -1 and 4 are interchange. ஸோ 4 இங்கே வந்துடணும், -1 இங்கே வந்துடணும். ஸோ அந்த அடையாளத்தை சேர்த்து கம்ப்ளீட்டாக மாற்றிடணும். இங்கே வந்து ரெண்டுமே ப்ளஸ்ஸாக இருந்ததுனால நமக்கு எந்த ஆட்சியும் இல்லை. ஸோ 1, 4 ரீப்ளேஸ் பண்ணியாச்சு. இங்கே -1 கீழே வந்துடணும், 4 மேலே போயிடணும். ஸோ சேஞ்ச் த சைன் ஆஃப் B and C. ஸோ 2 வந்து +2 இருக்குது. ஸோ -2. -3 வந்து +3. ரைட். ஸோ A inverse equal to 1 by determinant A 2 into adjoint of A. ஸோ 4 -2 3 -1.